Hey everyone, welcome to the 24th video of the playlist Leetcode Top Interview 150 question solutions. In this video, we will be solving the 24th problem in this list, and the name of the problem is text justification. It is being asked that we have been given an array of string words and a max width, and we have to format the text such that each line has max width characters and is fully left and right justified. You should pack the words in a greedy approach, that is, pack as many words as you can in each line, and pad extra spaces when necessary so that each line has exactly max width characters. Each space between words should be distributed as evenly as possible. If the number of spaces on a line does not divide equally, then the empty slots on the left will be assigned more spaces than the empty slots on the right. And for the last line, it should be left justified and no extra spaces inserted between words. So given this problem, let's try to work on this and then come up with an approach. Also, this question is tagged as Leetcode hard, and that's why it's a lengthy problem. So we are going to break down this problem into small understandable steps and see how we can write code for this. So here we have max width as 16. So 1, 2, 3, 4, 5, 6, 7, 8. So we have a max width of 16, and our job is to fit as many characters as we can in the line. So let's try to do that. So we have this, and then we have this. So each can take a one space. Then we have an. So let's try to fit an and see if we can do that. And we can. Let's try to fit an example, and then here. So when we are trying to fit as many words in the string, we see that at a point where we try to fit example in the same sentence, then we are not able to fit example because it exceeds the max width of 16 characters. So we won't be adding example to the list. Instead, what we will be doing is move the example to the next line. Now, the interesting thing is that we want this line of text to be justified. So the way we do that is, first we count the number of characters which are present in the string. So this is 4 characters plus 2 characters plus 2 characters. So line 1 has 8 characters. Now, when line 1 has 8 characters, then we have 8 extra spaces as well. Now, for this extra spaces, we have to distribute it such that it is justified equally. So the way first we figure out the number of spaces is by this formula. So num spaces would be total length minus total charge in line. So this is how we will come up with this number of spaces. Now, where exactly do we need to distribute the spaces? So as part of this question, it is being said that we have to distribute the spaces between the words if it is not the last line or if it is not the only word in the string. So in this case, we have to distribute 8 spaces between this section and this section. So as you can see, we have 2 different sections between 3 words. So we can also say available sections would be number of words on line minus 1. So we have to fit 8 spaces in these 2 sections. Now, in order to fit the spaces in these 2 sections, we have to calculate how much spaces we need in each section. So in order to do that, if we can divide the number of spaces by available sections, this will give us how many spaces should be there in between each words. So in this case, if we say 8 divided by 2, this gives us 4. So it means between these and is we should have 4 spaces. So let's add 4 spaces. Between is and there should be 4 spaces. So this should be 1, 2, 3, 4. Now you see this line has been correctly justified with given max width of 16 characters. And then we move on to the next line. We try to fit example there. Then we go to the next word. We try to fit it off. Then we go to the next word again. We try to fit text. And then we go to the next word justification. And the moment we try to fit that, it is exceeding the boundary of the max width allowed. So we cannot fit this in this line. So we skip this. We add it to the next line. And then for this line, we have to again justify this text. So now let's count the number of characters in the string. So its example has 3, 4, 5, 6, 7 characters. Then off has plus 2, 9, and then plus 4. So we have a total of 13 characters in this line. So let's calculate the number of spaces. So total length is 16 for the second line, and total characters is 13. So 16 minus 13 is 3. So we have 3 spaces here, here, and here, but we have to distribute them in a way that this line is left and right both justified. So to be able to calculate that, let's calculate again. So number of spaces, which is 3, divided by available sections, which is 2 again, because we have 3 words. So available sections is number of words on line minus 1. So 3 divided by 2. So 3 divided by 2 is 1, which means we should have at least 1 space between each word. So let's add 1 space between each words like this. But now we see that we have a remaining space, which is a remainder from this division, and we have no way to know where should we fix this. So if we take a look at the question again, it is saying extra space between words should be distributed as evenly as possible, which is the first part of the distribution. And then if there are remaining spaces which does not divide, as in this case, then we have to assign it to the empty slots starting left side of the line. So whatever is the remainder, so let's say number of spaces mod available sections. So this will be 3 mod 2, and this will also be 1. Now, however many number of non-divisible spaces we have, we start adding it from the left hand side of the available gaps. So let's add 1 here, and now we have used all the spaces we are allowed on this line. On the final line, we try to add justification, and since this is the last line, we have to handle it separately. So we again count the number of characters in this line. So we have 14 characters here, and we have 2 extra spaces. So what we will do is we will just add the remaining 2 spaces to make this last line also left justified. So there are a lot of moving parts in this question. At every line, we have to calculate how many number of spaces are remaining and how many available sections are there. So the approach for this problem will be start scanning the words from input. For every word, try to fit as many words in the line bounded by max width. Once we have found all the words which can fit the line, then calculate the spaces between the words and also the spaces which are extra, and fit them from left to right in the available sections. Finally, make sure that the last line or any line with only one word is always left justified. So this is going to be the approach for solving this problem. So let's go ahead and write code for this. So since the problem is asking us to return a list of string, this means that every line we are making, we have to convert it into a list of strings so that this total group of lines can be returned as a result. So let's create a result variable. So let's string result is new array list and return result. Now we are saying we have to scan every word. We try to fit as many words in the line bounded by max width. So let's create one more string list which will track the current line, and let's call it array list. Now while I is less than word slot length, so now we are considering every single word in the word slot length array, and this I should start at 0. What we want to do is we want to fit as many words in the line bounded by max width. So now to be able to do this, we would need a way to calculate how many characters in the current line are there, and if it is less than max width. So basically string word. So basically what I'm saying is by adding this word to the current line, would I still be lower or equal to max width? The total number of characters after adding this word in this line should be less than or equal to max width. If it is possible, then we consider adding this word in the current line. Otherwise, we don't. So to be able to track that, let's have a current chars variable which will store the total number of characters in the current line. So now length of current word would be word dot length, and if we are able to fit this current word into our current line, which means max width minus whatever number of characters we already have in the line minus adding this current word minus the total spaces we need on that line. If this all is greater than 0 or equal to 0, then only we will be able to include this word in the current line. Now let's also create a variable to track the number of spaces along with the characters in the current line. So now if this is possible, this means we are able to add the current word into the current line. So let's do that. So current line dot add word. The moment we do this, we have to increment the number of current chars. So current chars should be incremented by current word length. And after every word we add in the line, we also have to add an extra space. So let's add that as well. So let's increment the number of spaces in the line by 1 every time we add a word. Now since we have processed this word, we can move our I pointer to the next one and continue the loop. Now one thing to notice here is that every time we are processing a new line, which means current line dot size would be 0, then we need to reset the number of spaces on the line and the character as well. Also let's update the variable of this current chars to current line chars to indicate clearly that we want to store the total number of characters on the given line. Now in the other scenario where we are not able to fit the characters or the current word in this line, then in that case we have to make the line left and right justified first and then process the incoming word which should be shifted to the next line. So let's go ahead and do that. So left and right justify current line here. And I'm going to implement this function quickly. But after doing this, we also have to reset the current line by doing this. So let's define a new function to left justify and right justify the current line. And this takes the current line as the input, the max width, the total number of characters in current line, and a variable which tracks whether this line is the last line or not. So in this case, it's not. So let's do that. Now, whatever the result is being returned from this, we have to also append that result to this one. So we can say result.append at this. Now let's quickly go ahead and define this function. So public static string justified line string current line int max width int current line characters and boolean variable is last line. Now the responsibility of this method would be to take a current line and calculate the number of spaces which we discussed over here, that for every line whenever we want to justify, we have to calculate it how many spaces should be there between the words and what should we do with the remainder number of spaces, how to pad them from left to right. So this function would be responsible for handling that part. Now to be able to do that, we first need a lot of variables, which is the total length, total characters in line, total number of words on line, number of spaces, available sections, and so on. So let's create the variables to track these functions. So int number of words is current line dot size. This will give us the total number of words in the current line. Now let's calculate number of spaces remaining, and this will be max width minus the total number of characters in the current line. So max width minus current line characters. Now let's calculate the number of spaces which should be there between the words. So int number of spaces between words. Now this will be number of spaces remaining divided by number of words minus 1, as we discussed above in the formula. If there are 3 words, then we have 2 available sections, and the way to get there is divide the total number of available spaces by total number of words on line minus 1. So that's what we are going to do. So this will be number of spaces remaining divided by number of words minus 1. Now one thing to notice here is that if number of words is actually 1, so if we have only one word on the line, then this formula will fail. So we have to handle that test case separately. So number of words is 1, then we can return all the spaces as remaining spaces on the current line. So we can do this. Now we can calculate remainder number of spaces between words. So remainder number of spaces between words, and this again would be defined by the same formula. So if number of words is 1, then we don't need any spaces between words. Otherwise, the formula would be number of spaces remaining mod number of words minus 1. So now we have all the variables we need to be able to decide how to make the current line justified. Okay, so let's work on justifying the current line. Let's create a new variable called string builder result line, and this will be a new string builder, and this will be the placeholder justified line which we will be making shortly. So now for every word, so int I is equal to 0 again. Now for every word I is less than current line dot size. For every word on that line, we have to append that word first on the final string. So if we have 3 words, we first append this, and then we have to append the spaces. Then we again append the other word, then again we have to append the spaces. So let's do that. So result line dot append current line dot get I, which means we are appending the current word to the result line. Now once the word has been processed, we can increment the IR pointer. Now we have to append the spaces between the words here. Now if you look at the question, we had 2 different conditions for how we can append spaces, because the question requires us to have a fully left justified line for the last line. So we will have 2 different conditions. So if the current line is not a last line, then we append spaces in a different way. Otherwise, we do it in a different way. So let's have 2 conditions for that. And now let's handle the first condition. If we have number of spaces remaining and it is greater than 0, then we want to first append the number of spaces between words and then also adjust the remainder number of spaces. So let's say we here in this example we had 8 extra space. So in between we have to include 4 extra spaces. So let me just quickly define a helper function which will just append n number of spaces to a string builder. And we will be using this as a helper function to append the spaces correctly. So if we have number of spaces remaining greater than 0, then we are safe to append this number of spaces after we just added the word. So let's do that. So append spaces in the result line by this number of spaces between words. Okay. Now we have appended this many spaces, which means we can reduce the total number of spaces remaining by this number. Finally, we also have to adjust the remainder number of spaces between words. So if we have any remainder number of spaces, if remainder number of spaces is greater than 0, we will handle this now. And at this point, we will just copy this. And for remainder number of spaces, if we have any extra spaces, we are padding it one by one from left to right. So let's do that. So append spaces is that line, and here we only need to pad one space. And after that, we have to reduce the remainder number of spaces by 1. And we also need to reduce the total number of spaces, remaining spaces, by 1 as well. Now, for the last line, if we have number of spaces remaining greater than 0, and the current word is not the last word of the line, then according to the question, we have to keep this line as left justified. So we will keep appending spaces in the result line by 1, and we will reduce the number of spaces remaining by 1 as well. Finally, if it is the last word, then we are safe to append all the available spaces we have, and this can be denoted by this. Finally, we can say number of spaces remaining is equal to 0 because we have appended all the spaces. Once we have come out of this while loop, we can return the result line, which is justified as a string. And finally, after we come out of this bigger while loop, if we still have some values in the current line which was not processed as part of this while loop, we have to make another final justification again. So let's do that. So if current line dot size is not 0, then result dot add make justified line again, pass current line max width current line chars, and since this is going to be the last line, so we will pass 2 here. And finally, we are okay to return the result. And this is how the code looks like for the text justification problem. This question is marked as a hard problem, and the code is just very lengthy for this problem, but the approach is very simple. So let's try to go through the code once and see if we have missed something and try to fix that. If not, then we can try to run this code and see if we are able to pass the test cases. So looking at this line, we have to update the variable name here as well. And these values should be in brackets so that we don't have wrong values in number of spaces between words and the number of spaces. And I think here as well, when we want to see if this word is the last word or not, we have to check it by current line dot size minus 1, not just current line dot size. So rest looks good to me. So let's go ahead and try to run this code and see if we are able to pass the test cases. Yes, we are able to pass the test cases. So let's go ahead and submit this code. And we are able to get an accepted solution for the problem text justification. So in this video, we took a look at how to solve the text justification problem using the approach where we are justifying each line one by one by fitting the most number of words in one line, and then going ahead and justifying it by calculating the number of remaining spaces between words and padded spaces after taking a remainder from the total number of spaces. So in the next video, we will be solving the 25th problem from the Leetcode Top Interview 150 list.